Hi guys, welcome to this set of videos. And what we're going to do here in this set of videos is we're going to follow along with the notes that you guys have that come out of your textbook from Chapter 6, Section 5. Now what we're going to do here in this section is, again, we're going to kind of continue with this theme that we started in the previous section where we're going to simplify radicals. But now what we're going to look at is what happens if the power in the radicand and the index are not evenly divisible. That's the first kind of the situation we're going to work through simplifying. What if the power and the index are not evenly divisible? And then the second thing we're going to look at simplifying is actually the last little bit here in this list of things that you need to do in order for it to be completely simplified, and that is what is known as rationalizing the denominator, which I don't want to, steal my own thunder, so I'm going to hold off on that until we actually get to it. I love rationalizing the denominator. It's a ton of fun. But before we get to any of that, let's go ahead and take a look at our objectives or learning targets. These are the things you should be able to do by the time we get to the end of this set of videos, this set of notes. So let this kind of help focus you as we make our way through these notes, knowing what it is you'll need to be able to do by the time you get to the end. The first one is you'll need to be able to simplify radical expressions. And again, that was actually our objective in the last set of notes, simplify radical expressions. What we're going to do here in this set of notes is just look at slightly more and more trickier problems and sort of give you ways, techniques that you can use to help you kind of get out of a little bit more sticky situations. And then the last thing we're going to do here at the end of this set of notes is begin to look at operations that you can perform on radical expressions. And that would be to add, subtract, multiply, and divide those radical expressions. So we'll get to that after we've done a little bit more work with simplifying. So let's just go ahead and jump right into this. In order to simplify a radical expression, you need to make sure that you've done all four of these things. The index, n, is as small as possible. Okay, we've done that, no big deal. The radicand contains no factors other than 1. That means you've pulled out you've simplified everything as far as you can. The only factor everything has in common is 1. And let's see, that are nth powers of the integer or polynomial. Great, we're okay with all that. The radicand contains no fractions. We'll actually look at a couple of those here in both this set of notes and later sets of notes on later sections. Really the big one we're going to look at today is this one right here. No radicals, no radicals appear in the denominator. Essentially, that's a really fancy way of saying that we're going to rationalize the denominator. Rationalize the denominator. We'll get to that here in just a page or two and a couple of example problems here in the notes. Before we jump into simplifying a couple of these, I just want to remind you of the product property that allows us to, if you have anything underneath of a radical symbol that's multiplied, you can split those things up and take the nth root of each of those terms individually, each of those things separately. So let's go ahead and jump into simplifying a little bit of review from the previous section, as well as beginning to look at some slightly more complicated ones. So here we go, our first example problem. I want you to go ahead and simplify this guy right here. I want you to simplify the square root of 32x to the 8th. All right, well, we're going to start off with, a fairly simple one here. So what we want to do is we want to take the square root of 32. Now, again, 32 is not a perfect square. But what we have done before is found ways to simplify things that are not perfect squares by rewriting them as multiplication of some number and something else that is a perfect square. In this case, I believe 32, the best way to go would be a 2 times 16. So that's how we'll rewrite it. We're going to rewrite this as the square root of 2 times 16 times x to the 8th. Now the reason that I do that is I can't take the square root of 2, right? It's an irrational number, it's not a perfect square. But I can take the square root of 16. it's a 4. And what we saw in the last section of the notes was this. The power divided by the index gets you the simplified form. All you have to watch out for is that if the power is even in the original problem and you simplify to something that's odd, you just have to put it in square root or in absolute value. I'm not saying that's what's going to happen in this one, but just watch out for it. So here we go. The square root of 16 is going to be a 4. 8, right? That's my power. 8 divided by my index, which is 2. 8 divided by 2 is 4, so I wind up with x to the 4th, and I don't need absolute value because the power is even, and the power is even, and I'm just left with the square root of 2, which there isn't anything I can do with that, and I probably would write it in this order: 4 square roots of 2 times x to the 4th is going to be your simplified form for that particular example problem. All right, let's go ahead and try another one now that we've had a chance to review a little bit of what we did in the previous section. Let's take a look at this one. Now, what I'm going to be doing is taking a 4th root, no big deal. I'll be taking the 4th root of 16, which actually is one you probably should know, or at least could guess fairly quickly, that the 4th root of 16 is 2, right? 2 to the 4th power is 16. But the interesting thing about this one is this. I have a power of 24, which is divisible by 4. But I also have a power of 13, which is not divisible by 4. So now we kind of get a chance to take a look at, okay, what do we do if the power is not evenly divisible by the index? And here's what we're going to do. You're going to split it up. You're going to split it up into something that is divisible by the index and then whatever's left over. It's very, very simple. Let me show you how this is going to work. We are going to be taking the 4th root of 16, easy. We're going to be taking the 4th root of a to the 24th, easy. And then we're going to be taking the 4th root, and here's how this is going to work. 13 is not divisible by 4, but what I can do is I can split that b to the 13th up into a b to the 12th multiplied by a b to the 1st. Remember the way the properties of exponents work. If the bases are the same, you add the exponents. 12 plus 1 is 13. So this guy right here, b to the 12th, times a b to the 1st, is exactly what you originally had, a b to the 13th. I've just rewritten it such that now 12 is divisible by 4. No, 1 isn't divisible by 4. There's not really much you can do about that. In fact, it's actually very, very similar to what we did up here with real numbers. 32 is not a perfect square. So what do? Well, I split it up into a 2 and a 16. 16 is a perfect square, but 2 isn't. So yeah, I'm able to take the square root of 16 and get 4, but my final answer has a square root of 2 in it, because there's nothing I can do with it. It's an irrational number. It's not a perfect square. Well, guys, guess what? It works the exact same way here with the variables. Yes, I can now divide the 12 by a 4. Awesome. But it's like the 2. There's nothing I can really do with that b to the 4th except just leave it as the 4th root of b. And that's what we're going to have to do. So here we go. Let's go ahead. I think I can squeeze in one more line of work here just to help you guys see it. 4th root of 16 times the 4th root of a to the 24th times the 4th root of b to the 12th times the 4th root of b. Again, it's the product property that lets me split those guys up. Let's go ahead and simplify this. The 4th root of 16 is a 2. 24 divided by 4 is going to be 6, so I have a to the 6th. 12 divided by 4 is a 3, so I'll have b to the 3rd, and then there's nothing I can do, right? Remember, again, it's very, very much like the 2 up here, right there. I can't take the square root of a 2. so I just leave it as the square root of 2. Well, I can't take, right, 1 is not divisible by 4, right? There's no way to take the fourth root of a b, so we just leave it as the fourth root of b. And that is going to be your simplified form. There's nothing else you could do except check to see if you need absolute value signs. Well, here we go. 24 was an even power. It reduced to a 6, which is an even power. 13 was an odd power, reduced to a 3, which is an odd power. So I don't need any absolute value signs. Let's go ahead and try another one. All right, here we go. I have an index of 2. My first power is a 6. That is divisible by 2. 3 is not divisible by 2. No problem. Let's rewrite this guy. Oh, plus 12 is not a perfect square, so let's rewrite that guy as well. So here's what we're going to get. I'm going to rewrite this as the square root of 4 times 3 times c to the 6th times a d squared times d. We're going to take the square root of all of that. Again, what I've done is I've taken this d cubed and I've split it up into a d squared and a d. Why? Well, if the bases are the same, you add the exponents. 2 plus 1 is a 3. So I haven't changed anything. I've changed nothing. I've just simply rewritten the problem in such a way that now I can simplify. Square root of 4, well, that's a 2. Square root of 3, nothing I can do. It's just going to be a square root of 3. Power is 6, index is 2. 6 divided by 2 is a 3. Careful, I went from an even power to an odd power, put it in absolute value. C to the third power. D squared. Well, 2 is my power, 2 is my index. They cancel each other out. I'd be left with just a d. Careful, even to d to the first is an odd, so it's going to be the absolute value of d. And then I'm taking the square root of a d. There's nothing I can do with that. It's to the first power, which is not evenly divisible by 2, so we just leave it as the square root of d. Now, here's how you're going to want to rewrite these guys. Check your solution, and if you have anything that is under radicals, go ahead and put those guys together, right? It's going to be this product property in reverse, right? 4 times 3, if I put those guys together, I would get 12, right? So I'd have the square root of 12. Well, same thing here. If I have the square root of 3 and the square root of d, I put them together and I have the square root of 3d, right? I can just put those guys together. And that's exactly what we'll do. So I have 2 times the absolute value of a c cubed times the absolute value of a d times the square root of 3d. And there you guys go. That's going to be your simplified form for that one. Awesome. Really, really good work. Let's go ahead and do another one. All right, here's what I've got. I'm going to be taking a cubed root of 27. Actually, turns out 27 is a perfect cube. This should be one that you know. You know that 3 cubed is 27, so that's easy. 12 is divisible by 3, but 7 is not. So let's go ahead and rewrite this guy. 27 times a y to the 12th times a z to the 6th times z. Again, I have not changed anything. I've just rewritten it. 6 plus 1 is a 7. So I haven't changed anything. I've just rewritten it now in a way that I can simplify this guy. Let's go ahead and do that. Oh, sorry. My index is a 3. It's a cubed root. So the cubed root of 27 is a 3. That just simply means 3 to the third power is a 27. So that's going to come out to be a 3. 12 divided by 3 is 4. So y to the 4th. I don't need absolute value because it's an even power, so we're good. 6. My power is 6. My index is 3. 6 divided by 3 is 2. So I'd have a z squared. I don't need absolute value because it's an even power and an even power. And there's nothing you can do, right? 1 is not divisible by 3, so you just leave it as the cubed root of z. And that's it. That's all you can do. That one is simplified. All right, so what we've done now is we've taken a look at a couple of problems where if the power is not evenly divisible by the index, what do I do to kind of help me simplify that guy? And we just looked at a couple of those. Don't forget about absolute value. So now what we'll do is on the next page of notes, we'll start to take a look at what happens if you have a radical in the denominator and how we kind of deal with those. So head on over to the next page of the notes and I'll meet you guys there.